we're going to pick up right where we left off. This is part 2 of 7.1. I can identify and solve proportions. Proportions, spell that correctly. All right, and today we're going to focus on the method of cross-multiplying. Cross-multiplying. All right, so the problems are a little bit more complicated today. We've got a couple little twists to them, and there's a couple steps that you ought to be aware of, a couple little tricks that we ought to make sure that we do each time when we solve these. So here are a couple things that we're going to keep track of, especially if it contains a binomial. And a binomial is an expression with two terms. So you'll notice that this right here is a binomial. Bi means two, like bicycle, so this is a binomial and that's a monomial. You'll spend more time dealing with those later on. So put all binomials in parentheses. Parentheses. Okay, so the first thing we want to do is put them in parentheses. We want to cross multiply. And if there are parentheses, that's going to involve some distributing and that sort of thing. So the next thing is, of course, distribute and solve. So it says solve for the variable in the proportion, round to the nearest hundredth if necessary. So let's keep that whole rounding thing in mind. And then here's what we're going to do on this one right here. So on A, zoom in on this just a little bit. So you'll notice that there is a binomial right here. This bottom is an A plus a 3. So I'm going to go ahead and put that in parentheses. And we're going to multiply here, and we're going to multiply here. Now, if you want to go ahead and write down 4 times 4 on this side and then 2 times A plus 3 on this side, that would be totally fine. Normally, if it's an easy multiplication problem, I'm going to go ahead and write down 16. So I'm going to write down 16 on this side, and then of course I'm going to distribute through here. So this is going to be 2A, and then plus, this is going to be plus 6. And then this is now just a two-step equation, so we can solve that pretty easily. So we're going to subtract 6 from both sides. We get a 10 on this side, a 2A here. We're going to divide both sides by 2. Remember, we just divide by 2 because we want to keep the A over there. So that's going to leave an A on this side and put a 5 over here. So the answer on this one is A equals 5 or 5 equals A. Either way there. Now, if you can do a little bit of skipping here and you can distribute through and multiply these together in your head, that would be totally fine. You're not going to be able to do that on every one of them, but if you can manage that, then that would be great. So let's take a look at this right here. Again, we've got a binomial, so we're going to take our little hint here. We're going to put it in parentheses. So I'm going to multiply here, and I'm going to multiply here. So this is going to be 5 times y plus 2. And then over on this other side, we end up with 21y. So I'm just going to leave it like that, and then we'll go through and solve. So of course we're going to distribute. So this is going to be 5y plus 10 equals 21y. We've got a variable on each side. Now, it just so happens on this one it works out to be, that we do the right thing here. We usually move the smallest one. Now, that would be this one in this case. But on this particular problem, because we've got a variable on both sides and we've only got one constant, we'd move this one no matter what it was. We'd want to move that over there because that will save us a couple steps. So I'm going to move that to the other side by subtracting 5y. So we'll subtract 5y from both sides, and we end up with 10 over here, and we end up with, this is going to be a 16y. And then of course we want to finish this off by getting the y by itself, so we're going to divide by 16. So I'm going to go ahead and switch the order on this one, and we're going to reduce this. 2 goes in here 5 times, and 2 goes in here 8 times, so we end up with 5/8. So it turns out that we have a fraction answer for this one. No problem with that at all. Let's take a look at the next one. Again, we've got this binomial here, so I'm going to go ahead and multiply here and multiply here. So I'm going to write down 5 and n plus 10. And then on the other side, if you can do 10 times 7 and just go ahead and write down that that's 70, that's totally okay. I'm going to finish this off by distributing. So we get 5n plus 50 equals 70. We're going to move the 50 to the other side by subtracting. So that's going to leave a 20 over here and a 5n over there. And again, if I'm skipping a little bit, or you need to show more work or something like that, for example, subtract 50 from both sides and stuff, that's totally okay. You're welcome to do that. We're going to get the n by itself by dividing by 5, so we end up with n equals 4. Now, what this means on each one of these is if we were to take these numbers and plug them back in, they would make the equation, they would make the proportion true. So let's check that on this one right here. I'm going to change colors, and I'm going to plug this in right there. That would be 4 plus 10, so that's going to be 14 over 10. If we reduce that, 2 goes in here 7 times and 2 goes in here 5 times. So notice that we get exactly the fraction that's on the other side. So this is that whole idea that proportions are equivalent fractions. Okay, so let's go ahead and keep solving here. This one's a little bit more complicated. It happens to have two binomials here. So let's go ahead and multiply here and multiply here. So this is going to be 2 times x minus 6 on this side. So there's the 2 and there's the x minus 6. And then 9, and then this would be x minus 7. So we'll distribute through here. So we get 2x minus 12. And then 9x, and then this would be a negative 63. Now, as long as you're careful when you're doing these, turns out to be not too bad. And it's also great practice of how to solve equations. So let's keep that in mind. We are going to move the variable first. I'm going to move this one. Please don't move the constants, because then you never know, if they end up on the correct side or something like that. So here's what we're going to do. We're going to subtract 2x from both sides. If I'm getting the x's over on this side, I'm going to go ahead and move the 63 to the other side. So I'm going to add 63 to both sides. Whoops, 63. So those are going to cancel. This leaves a 7x on this side. So notice that it's nice. That's a positive coefficient. That's pretty awesome. And then let's see. That's going to be a positive 51. Yep, I think we're right there, because they're different signs. Find the difference. Keep the sign of the larger one. If you wanted to, we could always pull up a calculator and double check this. Negative 12 plus 63, and we end up with 51. So we're in good shape there. Now we're going to divide by 7, and then we've got a little problem here. 7 doesn't go into 51 evenly. So if I were to grab the calculator, and notice I'm just going to hit divide, it'll grab that answer. And we'll divide it by 7, so it doesn't go in evenly, and that's a really ugly decimal. Now remember, the instructions said go ahead and round to the nearest hundredth, but the original problem doesn't have any decimals in it, so we want to go ahead and write this down as a fraction. 7 is a prime number. It doesn't reduce at all, so we're not going to be able to reduce this. The cool thing about this particular problem is that right there is the answer, and I kind of like it when that happens. That's pretty awesome. Okay, let's take a look at this guy right here. We're going to multiply here and here. Notice that that's a binomial. Notice that we've got a variable in this denominator and that denominator. We can deal with that. We're going to do 4 times x minus 7. So we're going to multiply these around. When we cross multiply, we're going to multiply the x and the 9 together. And again, we're going to distribute. So this is going to be a 4x minus a 28. And on this side, we get a 9x. We're going to move that 4x to the other side by subtracting 4x. Negative 28, that's going to be a 5x. And then we're going to finish this off by dividing by 5. So we'll divide both sides by 5. And let's think about that for just a second. We've got a negative 28 over a positive 5. So the answer is going to be negative. Then the question is, does this reduce at all? It doesn't. So we end up with negative 28 fifths. We just circle that and we're all finished. Okay, last one. Okay, let's take a look at this right here, and you'll notice we've got some decimals in here, and there's a little box off to the side here, and there's an asterisk. So let's go ahead and read this. It says, remember, we only round at the very end of a problem. Rounding too soon introduces error. So let's take a look at this and see what we're talking about. So we'll definitely need a calculator for this one, because I don't want to multiply those together in my head. So 2.1 times 3.75. And then on the other side, 2.5 times b minus 2. Now I can handle this side, because when I distribute through, this is going to be 2.5b. And when I multiply through here, this is going to be negative 2 times 2.5. Well, that's 2.5, so that's going to be negative 5. So just to double check, I'm going to clear this off, and we're going to do 2.5 times, if you wanted to, you could put the negative in there. Okay, so negative 5, so we're in good shape there. And then we want to get this guy right here. So let's do 2.1 times 3.75. So when we multiply 2.1 times 3.75, you'll notice that we get something that's out to 3 decimal places. We're not going to round that, because if we round too soon, like we're not even close to the answer yet, if we round too soon, that's going to introduce some error, and it's just going to kind of compound itself as we go through. So this is 7.875. So 7.875. Get that to catch up here. There we go. Okay, so it's on there. Excellent. And then we're going to finish this off by adding 5. So those will cancel. So we'll have 2.5b on this side. Grab that calculator again. We're going to take that number, so I'm just going to hit plus, and we're going to add 5 to it. So we hit enter, 12.875, 12.875, and then we're going to divide by 2.5. All right, so we get our answer here on the calculator. So we're going to take that 12.875 and we're going to divide it by 2.5, and let's see what we get. So 5.15. So 5.15. So here's the cool thing. It turns out that even though we had 3 decimal places of accuracy here, once we did the division, we end up with 2 decimal places. It's a nice rational number. It doesn't go on forever. It doesn't have some non-repeating pattern or something like that. So we're in good shape, this right here. So please don't round until you get to the very end, and that's only if needed. Okay, let's take a look at the end here, and it's got a question. Okay, so it says, how would you solve an equation like the one below? So, my gosh, the equal sign is right there. This is a big mess on this side and kind of a mess over here. We've got some distributing to do and things like that. So I'm hoping you remember how to do this. So how do we solve an equation like the one below? We always simplify. So simplify, then solve, which means we simplify the sides, then we solve. So we'd look at this one. We're not even looking at the 2 sides. We're just looking at this side right here and saying, hey, you know what? Those are like terms. I'm going to go ahead and combine those. So that's negative 5x plus 5. So we're done with those guys. Then on this side we're going to distribute, so this is going to be negative 12x, and then this is going to be plus 3 minus 5x. So we get negative 5x plus 5, and some of you might see something that we could do at this stage, but let's go ahead with this guy right here. So this is negative 17x, and then this is a plus 3. Okay, so we got those. Now we've got this side simplified and we've got that side simplified. So we're going to go ahead and figure out which side we need the variable to end up on. Of negative 5x and negative 17x, negative 17x is the smallest. It's the most negative. It's the furthest left on the number line. So we're going to add 17x to both sides. Okay, and that means if we're going to get the x's over here, that means we need to move the constants on the other side. So we're going to subtract 5 from that side. So we end up with, this is a 12x on this side, so negative 5x plus 17x is 12x. And then 3 minus 5, that's going to be a negative 2. And we just have to finish this off by dividing. So we end up with x equals negative divided by positive is negative, and then we can reduce this. This would be 1/6. So negative 1/6 would be the answer there. So again, don't forget, just like we were doing up above, really what we were doing is we were simplifying the sides and then we solve. All right, good luck on the assignment.